All right, we're going to go through this. I've already put the answers on here for the numbers and operations section. And I've added this little section up here at the top. You're really going to want to focus your attention on rational versus irrational numbers and where they go on a number line. Like the square root of 10, where that goes on a number line. Scientific notation word problems. You got to know how to add, subtract, multiply, and divide. And when it gives you a question, how you are going to answer it, depending on whether you're going to add, subtract, multiply, or divide. All right. Remember, it's going to be about 20 questions on your test. Not even 20. It's going to be about 15. Which of the following numbers is irrational? For number 1, it's got to be D. Fractions are rational. This is A is a terminating decimal, and this is a repeating decimal. So if you're not sure, a terminating decimal is rational, repeating decimal is rational, and fractions are rational. So D has to be the irrational. It's a non-terminating decimal. Number 2, which of those lists contains an irrational number? You're looking for the one. Taylor, you see that pot? You see that little symbol right there? Say hello.
Hello.
Yeah. You see that little symbol right there?
Yes.
That's what we call an irrational number, okay? That means it goes on and on and on forever and it never repeats. Question number 3 says the square root of which number is irrational? You take the square root of 4 over 9. That's like saying the square root of 4 divided by the square root of 9. And the square root of 4 is 2, and the square root of 9 is 3. So that's going to be rational. The square root of 17 squared, remember that is inverse operations of one another. Those cancel each other out. And your answer is just 17. Square root of 256 is 16. And, anytime you take the square root, you need to be aware that you're going to have a positive and a negative answer. Square root of 8 is going to be your answer. That's the one that's irrational because it's not a perfect square. It's a perfect cube, not a perfect square. Number 4. I put this question on here because you are going to get a question or 2 or 3 or 10 on the milestone that you have no idea what they're talking about. All right? And it depends on your logic. It depends on how well you've built up your logic this year and in the past on how well you do. I mean, it says given the set of real numbers, Q equals, and then it has a set of numbers, -7, the negative square root of 2, -3 over 2, 0, 1. I mean, so you've got all these crazy numbers right here. It says identify the subset of Q whose elements are rational numbers. So, I don't even know what this question's asking me. But I do see that this right here, it says rational numbers. It says identify, and you see what your answer choices look like. Which one of these parts of the whole, so each one of these A, B, C, and D are going to be subsets of the entire set. And the entire set is all these numbers right here. Sure, you can talk. What do you got to say? What number do you see right here?
7.
Yeah, that's a 7. That's rational, okay?
Yeah.
You're going to pick which one of these groups has an irrational number in it. All right?
Me?
Yes. See that square root of 101? See that right there?
Yeah.
That's going to be irrational every time because it's not a perfect square. All right? So all of these numbers right here in A are rational numbers. They're either integers, they're fractions. They're either integers or they're fractions. Remember, negative has nothing to do with rational versus irrational. Number 5, pi goes in between 3 and 4 because it's 3.14. And then between which two whole numbers is the square root of 300. You figure out which two perfect squares is in between. It's in between 289, which is 17. And then this is going to be 18, which is 324. And my pen won't work on this side of the screen for some reason. So it's in between the square root of 324 and the square root of 289. So it's in between 17 and 18. So your answer is 6. C. All right. All right, Taylor, girl, what do you see right there? What numbers? Right here.
6.
No. What numbers do you see right here?
2.
Yeah. How many 2s do you see? 1, 2, 4, 5, 6. 7 2s. All right, cool. It says Mr. Chastain was grading papers when he got to Justin's paper. Question number 14 read, simplify the expression 2 to the fourth plus 2 to the third. Write your answer as a single number. So you're going to write your answer as an integer. Below is the question and answer that Justin provided. So he had 2 to the fourth plus 2 to the third. And he got 2 times 2 times 2. He multiplied them all together. He came up with 64 times 2, which is 128. Now, that is incorrect. Why did he mark this wrong? Guys, I put the answer down here. You need to write your answer in complete sentences. You need to say, Mr. Chastain marked this question wrong because, and then you give your reason why. The reason number 17, we hit this hard earlier in the year. All right, negative exponents. We talked about that a lot back in the fall. Negative exponents are not negative. It's another way of writing a very small number. It's the notation we use to present a very small number. And just remember our properties of exponents. The exponent is only talking to what it touches. This negative 4 is only touching the p, so it's only talking to the p. It's not talking to the 5. That would be a completely different question than if you had this. The negative 4 here is talking to the 5, but without the parentheses, it's only talking to the p. So what you would do is draw your division sign and put all of the powers that have negative exponent in the bottom, take away the negative sign, and everything that has a positive exponent, you put it in the top. Well, the exponent for 5 is just a 1, and that's positive the last I checked. So you get 5 over p to the fourth. That would be d. It's not b. Nothing about this number is negative. So you go ahead and get rid of those. And this is a very common error that kids make. They put it in the bottom of the fraction, but they forget to take away the negative sign. Number 18. Originally when I started doing this question, I started doing all this sort of stuff down here, as you can see right here. You didn't even need to do all that. Like, we have 4 7s in the top, and then you have 3 3s in the bottom. So if they're in the bottom, you would say it's 3 to the negative third. All right, or you'd say 1 over 3 to the third power. Well, if 3 to the third power is in the bottom, that must mean it has a negative exponent. It's asking you to work backwards. This is a great question. All right. If you, it would just take not so long, but if you had a calculator, it'd be no problem. But you're looking at whatever 49 times 49 is, and you're going to divide that by 27. That's just a headache. I don't want to have anything to do with that. But rewriting it with powers, that makes things a lot easier. All right. Number 19, if the base is the same and you're multiplying, you add the exponents together. So if we add negative 3 and then this value of n, that's what we're looking for. So we want to figure out what n is going to equal. You'd say negative 3 plus what gives me 7. Oh, so you would add 3 to this side, and you'd add 3 to this side. And then, or you like the boxes, if you did the boxes here, you'd have the n go right down in the box. Let me clean this up a little bit. You would have the n go right down in the box, and then you'd have the 3, and you would have the 7 on the right hand side because they're both integers. So we're saying negative 3 plus n equals 7. If you did the boxes here, it would say n equals 10. All right, n equals 7 plus 3. All right, your answer here is A. Number 20, this is just another, I put this one on here just because the notation looks a little bit different. 5 to the fourth times 5 squared, the base is the same. You're multiplying. Whenever you have parentheses touching each other, that's multiplication. That would be 5 to the 6th power. Base is the same, you're multiplying, you add the exponents, it'd be 5 to the 6th. This question is getting you to use your logic. That's what we've been talking about all year. If you know the process of what we're going through, if you know the process of how to use algebra, how to do properties of exponents, how to do PEMDAS, order of operations, this question is not that hard. If you struggle with any of that stuff, yeah, this is a very tough question. we're going to work from the inside out. We're going to do what's inside the parentheses first, but since we have multiple sets of parentheses, we're going to start with the inside. Well, x squared is being squared, and it's also being multiplied by -2. We're going to do exponents first. That's PEMDAS. You get negative 2x to the fourth. When you have a power raised to a power, you multiply the exponents. So you'd have 2 times 2, which gives you 4. So you have -2, or negative, and then -2x to the fourth power. And now what we just do is multiply -2 times x to the fourth, and you get -2x to the fourth. And the negative sign out in front of that is talking to the entire parentheses. So you'd say negative 2x to the fourth would be positive 2x to the fourth. Is there a 4 right there? I hope there is. That should be 2x to the fourth power. I think there's a little 4 right there. I just can't see it. All right. Number 22. All right. Question number 22 says we have 5 to the 10th times 2 to the 8th, and it's all divided by 10 to the 7th. This, I don't even want to think about doing this question without like writing it out in expanded form and simplifying it that way. Trying to answer this any other way it's just ridiculous. The numbers are so big, and then you'd have to divide them. So what we're going to do is we're going to write 5 to the 10th in expanded form like you see here. We wrote 5 10 times, and then we wrote 2 8 times. So that's what you see in the top there. And then in the bottom, you see 7 10s, okay? And if you notice, a 5 and a 2 that multiplies together give you 10, and you have a 10 on the top, 10 on the bottom. So therefore, that's going to cancel. So we're just going to kind of go through here. We're going to do 5 and 2, and that cancels out with a 10. And then a 5 and a 2, it cancels out with a 10. 5 and a 2, and we're just going to keep going like that until there's no more 10s in the bottom. When you multiply by 10 and divide by 10, that's like canceling each other out. Okay? So now we don't have anything in the bottom anymore. So now what we have is 5 times 5 times 5. And then times 2. Because everything in the bottom canceled out. We should have that 2 should be gone too. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. That 2 should be gone too. So you would just have 5 times 5 times 5 times 2, and that gives you 250. Okay? So it looks like it'd be a crazy big number, but it actually simplifies down because you have 10 to the 7th power in the bottom of the fraction. All right? Moving on. Question number 23. Choose all that are answers to 3 to the -3rd. I've went ahead and circled the ones that are correct. This one actually is as well. I is the same thing. Or I is, your answer is E, H, and I. All the other ones, nothing about this expression is negative. 3 to the -3 is another way of writing a very small number. So it would be a fraction. And so since nothing about it is negative, you go ahead and get rid of A, you go ahead and get rid of F, go ahead and get rid of D. Those are just, all right, man. Those are just some very, question number 24 I thought was important. It's not an 8th grade standard. However, it's the reason why we talk about math in the first place. It's logic, okay? We use statements like this all the time. If this, then this. That's what we call a conditional statement. The logic, we use this every day. You might not be graphing linear equations for the rest of your life, but you are going to use this logic for the rest of your life. If A equals B and B equals C, then A would equal C. I mean, it just kind of goes without statement. And you put a number in there for A. You know, if A is 30 and it equals B, that means B also has to equal 30. So if this is 30, that would mean this is 30. And if B is 30 and it's equal to C, then that means C is 30 also. That's the whole thing it's asking you, is if A is B and B is C, then A is C. All right? If we put 30s in there, it's going to satisfy that statement. So I just thought it was it's important because of the logic that we use there. All right, not necessarily an 8th grade concept, but number 25.
We've been answering questions like that since October. You multiply, you got to rearrange this sentence right here. We're going to put the integers next to the integers, the x's next to the x's, and the y's next to the y's, and then we have one z we're going to put next to each other. The one thing you have to remember here is that every exponent has every variable and number has an exponent. Even if it's not listed, it has an exponent of 1. So if the base same you're multiplying, you still have to add those exponents together. 2 plus 1 would give you 3, so you get x to the third. Alright, so your answer here would be B. Thing to remember about 26, we've talked about this in class. I'm not going to spend too much time on it. You have to distribute this 3 that's in the bottom, or this 3 that is talking to the entire parentheses. What kids would want to do here is they would want to say the bottom would simplify down to 2x to the 6th, y to the 3rd. And that's just not right, alright? The reason it's not correct is because that 3, the exponent on the outside, is talking to everything that's on the inside. So we're going to put a 3 that goes with the 2 as well. It's 2 to the 3rd, which would give you 8. Alright? So you would have 8 divided by 8, which is 1. And then x to the 3rd divided by x to the 6th. That'd give you x to the negative 3. So you put it on the bottom, make it positive. And then y squared divided by y to the 3rd. That's going to give you y to the negative 1. And that goes in the bottom of the fraction. You take away the negative sign. So your answer there is going to be B as well. Number 27, this says the cube root of 64. It says what times what times what gives you 64. You're looking for the same number multiplied by itself 3 times. That gives you, what number would give you 64? You know, you could just, your answer is not A. I'm glad I put that on there. Your answer is not A. Hold on, baby. The reason it's not A is because negative 4 times negative 4 times negative 4 would not give you 64. Now, that if we were talking about the square root, if that said the square root of 64, yeah, you'd say that has an answer of 8 and it has an answer of negative 8. But if it's the cube root, negative 4 times negative 4 would be positive 16. And 16 times negative 4, that would give you negative 64. And that's not what we have here. It's positive. So your answer is D. All right. 28, we're plugging 2 into that expression. The thing to remember on this question is, and this is always going to be one of the answer choices, what kids want to do is they want to do 3 times, it's not letting me right over there. We would have 3 times 2 to the 5th power, and what kids want to do is they want to do 3 times 2, which is 6, and then 6 to the 5th power, and that's wrong. You do exponents first. We're going to do 2 to the 5th power. What is that, 32, and then 32 times 3. That would give you 96. All right, so you got to do the exponents first. And number 29 says 4 friends played a game in which they rolled a cube or a dice twice. A number cube. Who says that? That's a die. A dice. Each person calculated their score by raising the first number they rolled to the power of the second number they rolled to. The results are shown in this table. So each one of these, I've outlined each one of these, how much each player would get. All right. Jim, 5 to the 4th, that's 5 4 times would be 625. Lisa is obviously going to be the most because it has 4 to the 5th. All right, you just have to figure it out for each one. All right. Question number 35 says Mr. Sanders gave his students a ticket out the door to see which students mastered the concept they discussed for the day. He asked the students to turn in the scientific. Okay, y'all can read. 8.32 times 10 to the 5th. Nico, this student, no offense, Nico, I know you get this right, buddy. It says this fictional Nico. He got the wrong answer. How do we know that this is incorrect? We want to write this in standard form, which standard form is another way of saying a number. Well, you would move the decimal in the direction to make this a large number because the exponent's positive. 10 to the 5th is a big number. You want to get a number that is quite large. If it said 10 to the negative 5, then you would need to get a number that's like this. All right, and that's all that question's asking. All right, Mr. Sanders knew that he was wrong because He moved the decimal in the wrong direction. I mean, you would want to write all this out very, very clearly to show everybody, to show the reader you know exactly what you're talking about. 36. Guys, this is like what's going to be on there. Definitely. All right. This is going to be on the milestone. This will be on the final. You got to know how to change, or you got to know what the question's asking you. In this question, it's saying the cost for constructing a shopping mall is 2.5 times 10 to the 7th. Cost for constructing a house is 2 times 10 to the 5th. How many times more? How many times more? How many times more? It doesn't say what's the difference. It says how many times greater does it cost to construct a shopping mall than a house? Well, if I said how many times greater is 12 than 3, you'd say 12 is 4 times greater than 3, because 3 times 4 gives you 12. So what you just did there, if I said how many times greater is 12 than 3, you'd say 12 divided by 3. You're dividing. You're going to do the same thing here. That's what we're dividing right here. How many times greater is that number than that one? You divide. And it says write your answer. The answers are all written in scientific notation. So you're going to want to pick the one that's the closest. 2 goes into 2.5, 1.25 times, and then 10 to the 7th divided by 10 to the 5th would give you 10 squared. So this is the answer that makes no sense. We already did number 37. I just wrote on there on accident twice. Quotient. See how many times that'll go in there. Y'all know how to divide. The base is the same. You're dividing. You subtract the exponents. Explain why this number is not written in scientific notation. Is because the first number has to be between 1 and 9.9999. We just talked about it up there. I used P, but this is using K. Alright, this is a good question. Oh, this is the last one. The closest star to our sun, Proxima Centauri, is 4 times 10 to the 13 kilometers away. Now, we don't generally talk about kilometers when we're talking about how far away something is in space. We talk about light years. This question says 4 times 10 to the 13 kilometers away. Closest galaxy to our sun is Canis Major. It's a dwarf galaxy, and it's 2 times 10 to the 17th kilometers away. That's a long way away. I mean, either way, that's a long way away. How many times further? There it is. How many times? You're saying which number multiplied that one would give you the other one. So you're dividing, which is the inverse. So you do 2 divided by 4, you get 0.5. And then 10 to the 17th divided by 10 to the 13th, that gives you 10 to the 4th. But this is, again, not a number between 1 and 9.999. You move the decimal one time, and you get 5 times 10 to the 3rd. Okay? On there, don't worry about this stuff right here. All right? That's just notation. Not even one of the signs is actually incorrect. This sign right here, but it just says why a number is rational is if you can make it into a fraction form. And both the numerator and denominator are real numbers, or rational numbers, rather. These are all the concepts that are going to be under the umbrella of numbers and operations, okay? All this stuff right here. And when we talk about scientific notation, add, subtract, multiply, and divide. And these are all the exponent rules that you're going to need to know. We just talked about each and every one of those up top somewhere. This says the square root of A is both b times b and negative b times negative b. So if your answer to this is saying the square root of 36 is both 6 times 6 and it's both negative 6 times negative 6. You have two roots, one positive, one negative, because a negative times a negative is positive. And then the last one, square root of anything squared, does cancel each other out. Okay? Y'all are going to do amazing. Keep it up. I believe in you.